Okay, hello once again, Algebra 2 students. You're going to see two videos for this week. This is the first video for the week of May 4th. So that was yesterday. And again, May 4th, may the force be with you. And so today is May 5th, so um, uh, be ready to get those two videos in line. And the second video that I give you guys, in the back of it, I'll flip this over and you'll have two homework questions. Okay. So first and foremost, let's talk about exponential growth. Notice I'm throwing this word out here, growth. Grow means to get larger, get bigger. Okay. This is something you've probably actually heard a lot recently, unfortunately, because of the whole coronavirus. You've heard about exponential growth and how that works. Okay. So I'm going to show you an example of what it looks like. So an exponential growth function, I'm going to write this down. F of x is equal to, now the word is actually in it, exponent, okay? What we've seen in the past is we've seen something like this. We've graphed x squared, x to the power 3. That base right there is a variable. This time around though, the other way around. I'm going to give it let's just say 2. I'm just going to throw it. That could be 3, it could be 4 or 5. I'm going to go 2 to the power of x. That variable of x is at the exponent. So it's 2 to the exponent and it is x. So 2 to the power of x. So what is that going to look like? Again, I don't know what time I'm doing this graph. Okay, let's assume we don't know this. So what I'm going to do is I am going to make a t-table first and foremost. Okay, so let's make a t-table. Let's think about what's the easiest number to plug in for x. Should almost always be 0. Okay, so I'm going to plug in 0 for x and see what I get. Okay, so that's going to be 2 to the power of 0. Keep in mind, anything to the power of 0 is always equal to 1. It is not equal to 0, so please be careful. 5 to the power of 0 is equal to 1. Negative 17 to the power of 0 is equal to 1. Anything to the power of 0 is equal to 1. So 2 to the power of 0 is equal to 1. 0, 1. Let's do 0. Next, why don't we try 1? 2 to the power of 1 is equal to 2. Cool. So 1 comma 2. 1 comma 2. Done. Let's keep going. How about 2? 2 to the power of, what are we trying? 2 is equal to 4. Cool. So that's 2 comma 4. 2 comma 4. Okay. Start to notice what's happening here. It's starting to curve a little bit. Well, let's see what happens. Let's now plug in 3. 2 to the power of 3 is equal to 2 times 2 times 2, which is 8. Okay, so that's 3 comma 8. 1, 2, 3, 4, 5, 6, 7, 8. So like here. Okay, that's starting to go up pretty fast now. If you notice, it's curving and it starts curving pretty fast. It's going up. I'm going to fast forward. You would never usually do this many, but let's go to 2 to the power of 4. Okay, so I'm going to try plugging in 4. That's going to give us 16. 2 times 2 times 2 times 2. So this is going up really fast. So 4 would give us 6. Now, I can't even reach 16. I can't, my whiteboard won't even reach it. But I know 16 is going to be somewhere ridiculously high, like up here. So if you notice what's happening is it starts going up, and then it starts getting up at a faster rate, and then it skyrockets up. And for 5, it's going to be 32, which is going to go to like, it's going to go pretty high. And then if I plug in 6, it's going to go to the ceiling of my room over here. Okay, so it'll go up really really fast. And that's when I said we're talking. This is related to coronavirus, for example, or any sort of infectious disease, a disease that's really infectious. In the beginning, some people have it. It starts going up, but then the more people have it, the more people get infected. But it's not like, oh, we double every day. No, it's like, it's getting exponentially faster. So it's getting fast, really, really fast. So maybe this might represent the number of days. By day 4, we have 16 people. By day 10, we could have thousands and thousands of people. Okay, so it's not like, oh, every day we're getting 2 new cases, or every day, or every time it's going up by 2. No, it's like going up really, really fast. All right, but I want to figure out what the tail end of this looks like. So I know it's going up that way. So how do I figure out the tail end? Well, we did 0, 1, 2, 3, 4. We did all that. Let's do -1 now. Let's see what happens there. -1. Okay? And this is where it gets interesting. I'm going to erase all this. Actually, you know what? Let me do -1 on the separate G table just so you guys can see it better. X, Y. I'm going to do -1. So that means 2 to the power of -1. Now remember, when you have a number to the power of a negative, just make it a fraction. Okay? It's kind of like flipping it. It's kind of, reciprocal. Okay? So that's going to be 1 over 2. So 2 to the power of -1 is going to be 1 over 2. Now simple, watch this. If I do to the -2, watch what happens. It's 2 to the power of -2. Well, think of it this way. Negative exponent is going to make this a fraction. And just ask them, what's 2 to the power of 2? Well, that is 4. So let's think of this. -3. What would that do? -3. 2 to the power of -3. Well, simple. It's going to be a fraction. 2 to the power of 3 is 2 times 2 times 2, which is 8. And so on and so on. You just keep going. So -4 is going to give us 1 over 16. And it just keeps going and going and going. Okay? I'm going to start graphing this now. See what happens. -1 and half. Well, half is going to be hard to graph. I'm just going to arbitrarily put it here. I mean, not exact, whatever. Okay? -2 is 1/4. So if this is 1/4 would be like what here? Again, not perfect, but I'm doing my best. -3, 1/8. Oh, that's getting really close. Like there. -4, 1/16. Okay, if this is 1/16 is like here. Oh my goodness. You know what would happen? If I do -5, I get even closer. 1/32. Oh my goodness, it's getting so close to that 0. But I want you to think about this. It's going to be 1 over 32. After 1 over 32, it's going to be 1 over 64. 1 over 128. It's going to get so close to that line, to the x-axis, to the 0. So close. But it's never actually going to hit 0. It'll never actually be 0. And you know how I know that, guys? Watch this. If I ask you this, 2 to the power of something is equal to 0. 2 to the power of what is equal to 0? You can't give me a number. It does not exist. It does not. There's no such number where 2 to the power of something equals to 0. That is undefined. It does not exist. That number does not exist. What you guys just found is called, and this is the major word here, that is called an asymptote. An asymptote is something that cannot exist. And in this case, our asymptote is, so 2 to the power of x equals whatever it equals to, you know it can't equal to y. I'm sorry, it can't equal to 0. So what can't equal 0? This y right here. Remember, f of x is like y. Y cannot equal to 0. If y cannot equal to 0, that's your asymptote. Y equals 0 is what cannot happen. So I'm going to do this in red because it cannot happen, okay? Y equals 0, which is this line right here. So on y, 0, y equals 0 is the equation of your asymptote. That is the equation of your asymptote. Now, what does an asymptote mean? So I'm going to draw this down. I'm going to keep drawing this graph. If you notice, this exponential graph is going to get so close to that asymptote, but we'll never actually touch it because this graph can never, ever touch the asymptote or obviously go below the asymptote because it can't touch it, it can't go below it either. Okay? So that is called the equation of the asymptote, which is y equals 0. And then going to the right, it shoots up. Now, I want to think about a couple things here. Let's find a y-intercept, which we already actually have, but let's just double check it. What would the y-intercept be? Well, simple. Y-intercept would make the x0. Let's make this x0. That's going to be 2 to the power of 0, which is anything to the power of 0 is 1. 0, 1, right over here. Well, we already knew that. Right there. X is 0, y equals 1. All right. So the y-intercept is 1. We already knew that. I'm just trying to show it to you guys again. All right, I'm going to erase this, and we're going to do domain and range. You guys ready? The domain and range. Okay. So, y-intercept we got. That's all good. That's all good. I'm going to leave the asymptote there, actually. Now let's do domain and range. Now remember, domain are your x values, range are your y values. Okay, let's do domain and range. Domain, left to right, all your x values. This is going to go forever left. So it's going to get really close to this asymptote. Just going to keep, just never going to go below that. Touch the asymptote to go below it. So it goes forever left. So the domain is negative infinity. The range, now, think about going for, I know it's going up really, really fast, but it's also going wider and wider, just like a parabola, just like a regular parabola. You know, it goes up, but it also goes to the right. So this is going up and to the right slightly. So it's going to keep going to the right very slowly. So it is going forever right. Negative infinity, positive infinity. Now let's talk about the range. Okay, let's agree on something. The range, when it comes to how far down it goes and how far up it goes. Okay, so down to up. Do we agree? We do agree that going up, oh hell yeah, this is going forever up. That is considered positive infinity. It is going to go up forever. But in terms of going down, it's a hard stop. It stops at 0. It does not go below this 0 point right here at y equals 0. So I'm going to put a 0 there. But here's my question. Do I put a bracket or do I put a parenthesis? Now, if you put a bracket, what you're telling me is it stops at 0, but it includes 0. So 0 and everything above it. So you're asking start at 0 and everything above it. But in reality, keep in mind your exponential function, the whole point of an asymptote is it never actually gets to 0. It doesn't actually touch 0. So we cannot put a bracket. The bracket would mean it starts at 0. It doesn't. It's just right above 0. It never actually touches 0. We actually have to put a parentheses there. Parentheses means, yeah, start there, but don't include 0. Okay, you're not actually, you know what I mean? So our asymptotes at y equals 0, we don't actually touch the 0. Okay, if I put a bracket, that would mean included. Without a bracket, that means don't include it. So the domain is negative infinity, positive infinity. The range is 0 to infinity. And we have a very simple exponential growth. Now, this is called the exponential growth if you look carefully, because it's going up like this. Okay, it's growing. Next video, I'm going to show you something else here, okay? I'm going to show you what happens if we mess around with that 2 here, that base. Okay. End of video number 1.